Have people here used OCaml or Reason before? The less hands, the better. My name is Piekarczyk, it's pronounced Piekarczyk, and today, as you already know, I'll be professing my love to ReasonML. All right, let's get started. That's how any profession takes place, right? Like really awkward and weird. Anyway, a little bit about me. I co-founded a company called Preact. We build cross-platform apps in minutes instead of months, literally. We have an amazing design system that we put together. So if you're interested in building a mobile app, building a React Native app, please reach out and we can talk more about it. Our compiler is written in Reason and it's super powerful. We're working on, with everything that's been going on with Airbnb and React Native, we will be offering like a Swift or Kotlin sort of export too down the road. So anyway, let's get started with a time frame of like 2010 to 2015, right? What was life like without React, right? What were we doing? We were using stuff like Bower and jQuery, vanilla JavaScript. Imperative programming was the name of the game, right? That was like the buzzword back then. You tell a machine to fetch some data, then to process it, and then finally to render it whenever you were ready, right? Back then, HTML and JavaScript did not get along. They lived in separate files. Can you believe it? And we all followed the MVC programming model, right? Model view controller, right? No matter what framework you were using at the time, there was a way to just like a path of success, right? And then what happened? Well, then React came about, right? And that sort of changed the game. This is a slide from 2015 at JSConf when I was like showcasing Trunk Club's Brunch with Panache infrastructure. We had 20 single-page apps. You know, all our stuff on the server was Ruby, so we had amazing like Rails-like routes on the front end. We were using CoffeeScript, right? We were using all this stuff that was great, but you know, there was something that we kept like longing for, right? Like, so then we sort of discovered React just on a whim, and what we started doing is mounting it to our certain backbone views, right? Do you remember the early days of React, right? You wouldn't just do create React app and your entire app would be React. You'd use it for bits and pieces of your code base, right? And well, 2015 and beyond sort of changed the game and ecosystem for us, right? We got React, right? We were so used to that MVC model, right? But React always says, we're just the view, we're just the view. And I'm like, what about the rest? Like, what about the model and the controller, right? And we all did different things to try to solve that problem, right? Things that we don't want to talk about anymore, right? Which is okay. Facebook gave us Flux, right? They gave us a reference implementation and said, hey, here's like how we think you should do it. Now somebody, you know, go make an awesome framework to make that happen, right? And the whole, like the big picture message was unidirectional data flow, right? I come from an Angular background. I knew two-way binding and I knew like ng view. I'm like, what the hell is unidirectional? How does it work? Like, how do I pass stuff back out, right? It just didn't click. It didn't click for a while. Dan Abramoff came out with Redux, right, with that reference implementation. And that sort of made our lives a little easier, right? We're like, oh, okay, now at least we've got some sort of a strategy, right? Like we've got this whole state tree, and what we're going to do is just take chunks of that state tree and just like manipulate the data or pull data in. Excuse me. So then what happened? We started pushing all this data down into the client, right? And we had rendering issues, right? The performance that we wanted, the performance that we were sold on, wasn't really there. So we learned about shallow comparisons and shallow copies and deep, right, and immutable data structures, right? Like comparing two strings or, you know, like what do you do when you have an entire nested object, right? You don't go through and compare every single key and value to that object, right? Immutable data structures was a phrase that started being tossed around. That's where immutable JS came in, right? Immutable JS gave us data structures like set and map, right? It handled a lot of the immutability cases that we needed to make sure that our apps performed well, right? So our apps were performing better, right? We started utilizing some of these tools, whether it was immutable, whether it was immer, or whether it was, you know, any variety of those tools. We came up with a solution to make that work, right? And then what happened? Well, we were making, like just goofy errors, right? Things were complex. JavaScript isn't easy, right? Like that's a whole nother conference talk. So the world gave us TypeScript and flow type, right? Now we can add some soundness. Now we can add some type safety to our code, right? With a simple pragma, just a commented out at flow at the top of your file, you can now add some type safety, right? But the beauty of flow type was a blessing and a curse, right? Nothing says that you had to make sure that everything was typed, right? Flow would only know what you give it, right? So other things would just have to figure out a way to account for it. So it was a solution, but we kept on, longing for more. And on top of all that, like that wasn't enough technology to mess around with in like a 18-month time span. We got a brand new package manager because the dependency resolution in NPM isn't what it's supposed to be, right? So what happens when you take all this stuff, right, put it behind a battle-tested ecosystem in a statically typed language? You get ReasonML. So you get a one-stop, one-way solution to handle all of your problems in a language that's familiar to JavaScript. So what is ReasonML? It's actually created by the same person who created React. It uses a familiar syntax to JavaScript, but sits on top of the OCaml AST. And you'll hear me say OCaml a lot through all this. The OCaml ecosystem that powers all this under the hood is battle tested. It's been around forever, and it can just do magical things. And the one part that Reason does add to OCaml is the friendly compiler errors and messages and warnings. You can learn a lot from just looking at a compiler message, right? Imagine debugging something in JavaScript, and it turns out that you misspelled something in a promise. Like, how long would that take to figure out? Like, we've all been there, right? Those aren't easy tasks to fix, right? Reason would let you know immediately. So, in a sentence, it's JavaScript as a statically typed functional language with a super fast compiler and amazing error messages. And like I mentioned before, if it compiles, it works, right? How many times have you been in a situation where things work beautifully in development, right, and then fall apart in production? How many times do you spend, like, looking for like a null error, right? Like, oh, this was supposed to be an object, and it's freaking null, and it breaks the entire flow, the project, right? Like, how many times have you had to deal with that? Well, the nice thing about having a statically typed language and a compiler up front is that these things are figured out right away. Don't get me wrong, the anger and frustration is still there, except it doesn't happen at night when you're sleeping, right? It happens immediately at work. So, anyway, so why would you consider Reason, right? High-level overview. We'll go through these and break these down one by one. Compiles 10 times faster than Babel, right? It is so astonishing to me when I have to go back to just a create React app setup with a whole bunch of stuff in it, and then have to deal with how long it takes to compile. It doesn't seem like it's bad, right? Because it is relatively fast. But when you're in the OCaml Reason space, it's instant. It is remarkable what they're capable of doing. And like I mentioned before, with the compiler, we can get rid of a lot of the weird errors that we run into, right? Because everything is 100% code covered, right? We will always know exactly what the types are of a problem at any given time. And one really exciting thing about all this is compiling down to native binaries. So it's not ready yet, right? We all saw what was going on with React Native. Airbnb says, hey, this is a fantastic tool, but we need, we're in that like 1% of people who need like ultra high performance, right? Like this works for 90% of you, but we need this 1% of ultra high performance. Well, with Reason, you'll actually be able to skip the React Native step and compile directly down to native iOS and native Android. And also another cool part about it is the whole idea of like unit kernels. So at a high level, right now, if you want to run an app on a server, right, chances are you're installing Linux or, you know, Ubuntu, right, like something on DigitalOcean or, you know, EC2 instance, right, and then dropping your JavaScript application onto it. Well, these OCaml wizards all got together and built a lot of these operating system style packages into their own thing. So you could take OCaml's TCP/IP stack, your application bundled together, and run it directly on a hypervisor or VM or bare metal. That's really exciting stuff, right? You may not do it with a JavaScript application, right? But there's amazing potential for it. And lastly, one of the goals of Reason is readable compiled JavaScript. The stuff that it compiles isn't mangled. It doesn't look weird, right? If you've ever used like ClojureScript or anything else that does the same thing like mscriptum, a lot of the stuff that you see isn't readable, right? It just doesn't make sense. And sometimes, you know, things do get lost in translation, right? Sometimes you may figure out that, oh, well, it worked in, you know, like it worked in my source code, but it, you know, broke in this compiled code. Let me try to read through it, right? Like, it never works out nicely. This makes that a lot easier. All right, so Reason is a pretty new language, right? It hasn't been around for, you know, publicly more than a year and a half, right? Who's using it? You'd expect to see a lot of small companies on this board, but it is actually quite different. Bloomberg, you know, Bloomberg Terminal, the big financial company, they're the ones that open sourced BuckleScript, the OCaml to JavaScript compiler in 2016, right? They've been playing a huge role in Reason. Facebook, obviously, Facebook makes Reason, so they're going to use it. Messenger.com is actually their testing ground. So any new Reason features that come in go directly into Messenger, and that's the platform team that makes sure that we get the developer experience that we want. Accenture was the big sponsor of ReasonConf, right? They're using a lot of it in their emerging tech division. Jane Street, a high-frequency trading firm that's been part of the OCaml community for years, is looking at Reason to onboard and bring on more amazing developers. And lastly, DraftBait, my company, not as big as any of these, but we're using it for our compiler. So, shameless plug. Anyway, let's talk a little bit about the Messenger.com platform. In September, Facebook released a post of their work with Reason for the last year. Over 50% of the Reason code base, or of the Messenger code base, was in Reason, right? Now they're close to 100. But during that time, a full rebuild, hundreds and hundreds of files, because everything at Facebook is a component, was 2 seconds. Incremental rebuilds, right? You're just making changes to individual files, less than 100 milliseconds every single time. So what used to be 10 bug reports every week or more has been 10 bugs for the entire year. They were able to get rid of 90% of the bugs just by using something like this. Refactoring was reduced to minutes instead of days. Why? Because you no longer have this like JIT runtime, right? Like you can do a lot of analysis on your code base and just like move stuff around in a way that you've never experienced with JavaScript. So I mentioned briefly some of the compiler stuff. Let's talk about it. What does it look like, right? So typically when we've used compilers in the past, things don't look nice, right? They just break down on you. Reason puts a lot of time and effort into making sure that things are readable, right? So in this case, it's pretty obvious what the issue is, right? The modular file and map can't be found. I know there's no context around this right now, but I'll show you later on. So what does it say? So if it's a third-party dependency, did you get it from somewhere else, right? Did you list it in your config, right? Did you run DSB, which is like sort of like the build function, right? Did you include it in the files directories, right? You'd be able to instantly figure out what the issue was instead of trying to dig around, like, you know, and do your sanity checks, right? Like, all right, files there, you know, npm install, you know, rmrf node modules, right? You don't have to do any of that, right? The answer lies right in front of you. In this case, I'm using a type variant and a pattern matching case, right? So something that I'll show in a second here is a bunch of types, right? So we know that a variable may have 3 different answers, right? And when we match for that, right, we have to match for all 3 of those cases. Well, I've forgotten to match that case. The answer is right here in front of me. That's some really powerful stuff that I've never had in JavaScript, no matter what tooling I use. So the compile times are unreal, right? Just the way that OCaml's been built and the work that it's gone through over the last 25 or 30 years has made it really, really fast. So somebody did a benchmark across a variety of different languages, right, and broke it down. In Scala, it took 5 seconds to compile that piece of code. TypeScript, 1.8 seconds. And in OCaml, 0.02, right? Like, that's blazingly fast, right? It's not a second difference, right? It's like 99% faster, right? Okay, moving on to the next topic. The compiled JavaScript is readable, right? Everything that you do makes sense. So in this case, here's a Reason implementation of FizzBuzz, right? It's pretty straightforward. I'm using a switch statement, and then the bars that you see here is called pattern matching, which I'll dive into next. What does this look like compiled? It looks like this, right? That's readable JavaScript. You may think that this is a questionable variable name, and it is, right? But if you can get over that, like, this could be something that your coworker may have written, right? It's nothing that looks like too out of the ordinary. In this case, just a quick factorial implementation, right? This is just using a ternary statement and some inversion, right? The JavaScript version of this, there is something new, right? A require statement, something that you've never seen before with camel in 32. But you know how require statements look like, how it work, right? And besides that weird function thing, right, that like a lot of us have never seen before, it's just readable JavaScript, right? You may turn around and be like, why the hell did you use this? And then your coworker may be like, that was Reason, So anyway. The nice part about all this too is that it's faster than handwritten JavaScript, right? JavaScript performance is really hard to get down right? And it's really hard to explain too, right? Not only do we have a bunch of different platforms, right? A bunch of different browsers to support, right? Some functions are faster in one browser and slower in the other, right? And trying to explain everything that happens behind the scenes and trying to make JavaScript fast is like a career of its own, right? Like, there's usually somebody that knows how to just like do it, right? Like, that's not a thing that we all know how to do. At least I don't. Maybe all of you do. Anyway, I came up with this silly, well, I didn't come up with this test. I copied this test, but I copied it onto this slide. So anyway, this is some Reason, and what it's doing is I'll show you the JavaScript version instead, right? So that was Reason, and what we're doing here is we're just like adding things to an immutable map, right? Facebook's immutable is really, really fast, right? And this is probably the fastest way in JavaScript to just like add a bunch of things, right? If you were to test this, the results would be astonishing. So Reason's version of the immutable map took 1,100 seconds to execute. Facebook's immutable map, right, like I said, which is probably the fastest implementation out there, took 3.5 milliseconds. The tree shaking is optimized too, right? So Webpack, you know how much time we spend trying to get Webpack right, trying to figure out tree shaking, right? Now there's Babili, which is ES6 aware tree shaking, that's a part of Babel, right? All that stuff is so time consuming, right? Just because of the functional nature of OCaml and the compiler and the static type checking, we get tree shaking for free, right? So in BuckleScript, which I'll talk about in a second here, that came down to 899 bytes. Whereas immutable.js was 55 kilobytes. And you'd imagine a library like that from Facebook, from the same folks who made Yarn, right, the package manager, they would sort of understand how tree shaking works, right? They would be able to get this down. And this is the best they could do. How, right? Just like I mentioned a second ago, it's because everything happens at compile time, right? OCaml's functional nature just makes a lot of this stuff a lot easier. So what is OCaml? What role does OCaml have in all this? Well, it's the same semantics with different syntax. And to explain, here's sort of just a great diagram of compile targets, right? So whether you have Reason or OCaml or both, right? In a project, you could arguably have Reason code and an OCaml. The OCaml AST, which is it's an abstract syntax tree, compiles it all down, sort of the same way that Babel works, right? So chances are, if you're at this React Chicago meetup, you're using Babel, right? And Babel compiles your stuff down into an abstract syntax tree too, which can then choose different targets, right? ES3 or whatever. Anyway, OCaml works the same way. But in this case, we have some really, really powerful compile targets. You can compile down to bytecode using OCaml C. You can compile down to native code using OCaml opt. And then finally, the one that we're going to spend all of our time on is bucklescript compiled down to JavaScript. So why OCaml? You know, who said that OCaml was the right language for all of this? Like, who wants me to stop writing JavaScript? Well, OCaml is actually a really, really established language with a battle-tested ecosystem. It's been around since 1996, and it's used in a lot of high-performing apps, right? If you really need performance, right, you're not using JavaScript, right? Like, you're using something else. And there's a good chance that you're using OCaml. Facebook internally uses OCaml for a lot of different tools. Flowtype was actually written in OCaml. And HAP, which is their PHP version that they run on the server, was also written in OCaml, right? And just based on all the research Jordan's done, the first version of React was actually written in standard ML, right? So you might be wondering, why did Jordan use standard ML at first, right? And why didn't that take off, back when it did? Well, going back to what we were talking about in 2010, right? Jordan was a couple of years ahead of us, right? So Babel became a really popular thing in 2015, right? That's what we were starting to use. We were starting to understand what it means to compile down your JavaScript, right? Before that, we were all like, what do you mean? It's already compiled, right? It just runs. We don't need to do that, right? So we started getting used to that. Bucklescript then releases, or Bloomberg then releases bucklescript, right? Now take your OCaml code and turn it into something readable, right? Jordan went back in the meantime while all this was happening and rewrote React in OCaml, right? I didn't like standard ML, right? It wasn't going to be easy for the people to, adopt it, so let me try something new, right? And that's when he believed the world was ready, right? We were using compilers of our own. We were being introduced to immutable data structures and functional programming, right? It was a step in the right direction to get us to use something like Reason. So back when Jordan was first coming out with the first versions of React, none of this stuff existed, right? Bower didn't exist. Angular didn't exist, right? The web, I think we were just getting past, scripts that we would copy from SourceForge, right? These were the earliest days. And Jordan was already thinking about a solution to, render these components in a declarative style, right? How many different frameworks have passed before we got all this, right? So adoption would have been hard at the time, right? Imagine if in 2012 or 2013 this whole thing came out, right? I would be like, I don't know what a compiler is. I'm just going to go back to writing jQuery. You can do whatever you want, right? So because of all those issues, React came first, right? It's sort of like how Steve Jobs really wanted, I think, the iPad to come out, but the screens weren't big enough. So he's like, I'm going to try to do this thing called the iPhone, and maybe that'll take off, but the plan is really supposed to be tablets, right? I guess you could sort of see that as the same approach. So is Reason ready? Yeah. It's really ready, and it's been used at a lot of places in production, and it's really fast, and it's only getting better. And anytime there is a breaking change in Reason, it comes with a set of tools that help you convert automatically, right? So maybe you've heard of code mods in JavaScript, right, where you can convert all your required statements to imports, right? And it'll just do all the magic work. It could convert your React.create class to components or classes or components, right? All the tools are actually written in Reason, and it's so much easier to write those tools in Reason. Anyway, let's talk a little bit about BuckleScript. So, BuckleScript is the solution that compiles your OCaml to JavaScript, right? And their pitch is write safer and simpler code in OCaml or Reason that compiles to JavaScript. And BuckleScript has a few goals. They're not the first ones that came up with this whole system of compiling, right? There's been Inscriptum, there's like OCaml to JS, right? There's a bunch of other variations and varieties, but the reason why it works well with Reason is because they share the same goals. The JavaScript needs to be readable, right? It supports the entire ecosystem. So you can import your JavaScript modules into your Reason code, right? You don't have to rewrite anything, right? And it compiles really, really fast. If I haven't said that enough times, like, it's really, really fast. So how do you do that? How can you import your current JavaScript files into Reason, right? And get a lot of those benefits? Well, you just write the bindings. And so if you're looking for bindings, right, I would definitely say don't start out writing bindings. You're going to have a really bad time. But if you're looking for bindings, a lot of them, for the most popular packages, are already there, right? And they look like this. So anything prefixed with BS. BS React Native, BS Fetch, BS Moment, BS Express, BS Apollo, right? Like, there's bindings for any big package that you're using today. And this is what bindings sort of look like. I know this is a lot. I still don't understand all this sometimes, right? But anyway, what you're doing is you're taking functions from the JavaScript side, right? You've got some sort of API. Let's say it's a class with some methods, right? Or an object with some keys. You're taking those things and then saying or telling Reason, like, this is the type for that. This is going to be a string. This is going to be a function, right? So sort of like you're using flow type, except this isn't nice. Flow type is nice. I'm just saying, oh, you messed it up, right? Like, fix it. And you can listen to that or move on with your life, right? Like, this will not compile unless you get it right. So if I haven't, like, said a bad thing about Reason yet, like, this is like the hardest part, writing bindings. Like, avoid that for as long as you can, get comfortable with the language first, and then consider bindings, because it's not easy yet, right? So let's get into some of the language features, right? So what makes Reason so good? Well, the types, right? And this works similar to flow type in TypeScript and types in any language, right? The nice part is types can be inferred, so you don't always have to type everything, right? There's a lot of times where the compiler will just figure out, like, oh, this must be a string, or this must be, a function that consumes a string, right? There is no code coverage tool for Reason because everything is 100% covered, right? You don't have to do anything special. Everything is safe and sound. So what does a type look like? Well, something like this, right? The top line is totally fair game, right? But if you want to be explicit, you can annotate the type underneath. If you've ever, like I said, used flow type or TypeScript, you're probably used to this. If you ever use any, statically typed language, you've got a lot of this happening. So this is a little more complex. So focus up on this thing right here, right? So we have a type of int coordinates, and what you see there is a tuple, right? So it's a data structure that doesn't exist in JavaScript, but basically it's like a pair, right? Sometimes you'll see them in JavaScript treated as like an array, right? It'll just be like 0 index and 1 index, right? Anyway, that's a tuple, and these int coordinates, right, are 2 ints, right? Well, sometimes it's nice to be able to reuse these things, right? We're not in a position where we see int coordinates very often. They're usually like floats, right? Something with a bunch of different, decimal places and numbers, right? So how can we reuse those same types in both places? Well, it's something like this. So now we have a type coordinate that takes an argument So types here can take arguments the same way functions do in JavaScript. And they're prefixed with this little apostrophe thing right there, right? And the A doesn't matter. You can write alpha, beta, right? In the OCaml world, it's usually A, B, whatever. And then T is like your default type, right? Alpha, beta, so on and so forth, right? So then what we can do is we can make int coordinates using this type that we've already created. And sometimes you'll do it this way, but most likely you'll probably use one of these patterns down here, right? So going back to what you saw on the other page, we annotated in line, right? So we know house is going to have the coordinates, or going to have a type with this two tuples, and it's going to be a float type, right? But OCaml is smart enough to just let you do this, and it can infer right off the bat that, oh, those must be floats. They will always be floats. We won't let you do anything with them that doesn't correspond with floats. Another really, really powerful and amazing feature is variance, right? So in this case, we have a type called myResponseVariant. And these bars mean or, right? So in languages, like we're used to like this and that, right? Like usually that's as far as the type goes, right? It could be both of these things. It can't be either of them. OCaml gives us the ability to choose, right? This or that, right? And these things that you see here, these are called tags or constructors, right? In the same way that in JavaScript a constructor takes arguments, these types can also, or these tags can also take arguments. So in this case, we're setting, are you crushing it to yes, right? On this next slide, I'm going to introduce pattern matching to you, which is another really, really powerful, awesome feature. If you're going to start doing anything with Reason, mess around with this stuff first. So we have a variable that we defined above that was, are you crushing it, right? We want to match with the right variable, right? So do you remember that initial compiler message that I got that said, you know, you must be missing something, we're not going to compile your code? It's because I was missing this. This just wasn't there, right? And it literally said, no, like we're not even going to run this for you because you forgot a freaking case right here, right? That's really powerful. And anyway, what we do here is, are you crushing it goes through, right? No, yes, or pretty much, right? And it just matches that case, and in this case renders a string. And pattern matching works with any sort of type in OCaml. Types and variants are really, really cool, but it works with just like a string here too, right? So what are we looking for? We're looking to match the message against a few things here. So you can match an entire sentence, right? Reason's pretty cool, right? You can match just like this. It's another same case. The interesting case here is this one, right? Hello and hey, right? Now you're doing kind of like a sub-match, right? And in this case alone, it can match either hello or hey and give you that. Or the same way that JavaScript's switch statement default works, you can just pass in an underscore, and anything that doesn't go through is at least matched by this underscore. And the result of this is obviously nice to meet you, since I passed in sub, and none of these cases match, because this person isn't proper. Okay, so another really cool feature is modules. So in Reason, you'll notice that it's really, really hard to nest or share a file with a bunch of different components, right? Usually everything that you'll do will be in one file, right? Like every component is its own file. You'll get used to it. It makes life easy. Sometimes though, you're just like, this has to live in there, right? Modules make that process a lot easier, right? So modules are treated as mini files that you can include in a lot of different places. They include types, they include more modules inside of them, and they can be opened or extended. And this last one was the hardest for me to really understand. So hopefully this will make your life easier when you start looking through Reason code and seeing a lot of these opens. So what does a module look like? Well, it's pretty simple actually, right? So this whole thing is just sort of encapsulated, right? It's sort of like a function in JavaScript that has its own variables, except it's not JavaScript and it won't let you do silly things. So in this case, we have a type of profession, which is teacher, right? And then something happens here, right? We have some sort of code. In this case, it's just another pattern match, right? Well, we can use that, right, the same way you may store stuff in like a function or a constructor, right, and assign things that the app will be able to read into all of this. And so in this case, another person is a type of school.profession, right, and we are assigning it to school.teacher. So the module opens, right? There's two types of opens. There's global opens, and this you'll see a lot. As soon as you start writing a React Native app, you'll see this everywhere. And basically, what it's saying is, I don't want to write bsreactnative.stylesheet everywhere. I just want to open it up and just use the API underneath it. So, unlike JavaScript, where you have to import every single component or file that you want to use, in Reason, everything is available for you at all times, anywhere. And instead of having to deal with like scoping issues or whatever, right? You just don't. So, but to make your life easier, you can set up a global open and not have to rewrite that entire word every single time. Now, there's another type of open, and this was the most confusing part, and that was the local open, right? So, as you can see, since I opened this up here, I don't have to write bsreactnative.stylesheet, right? But then I do this weird thing down here with a dot in front of it, right? Like, why is there a dot and then some parentheses around it? This part has a bunch of style sheet code, right? Stylesheet.create, container, label, yada, 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 right? What this is saying is there's a type called style that's got a lot of different attributes. Border color, border radius, background color, font family, right? Font size, all the different CSS attributes that you use, right? And instead of writing style.background color and style.font size every single time, you can do a local open, and that scopes it within those parentheses. So, we are at React Chicago, and it's about time we start talking about React, right? So, how do you do that? You've probably noticed online that it's not React anymore. It's ReactJS, right? And they literally make it a point to say ReactJS right now because of ReasonReact, right? Facebook is going to start pushing this more and more as their go-to way of building React components. And it's not a rewrite. It's not a rewrite at all. They're actually working on one, but that's happening somewhere else. It's just the bindings. The same bindings that we've talked about, the core team went through and created bindings for every part of the React API, so you can start using it. It uses the exact same code under the hood. But it's all super type-safe and just works the way you want it to. So, what does it look like? This is an entire component, right? Some things here look really, really similar, right? And some things here are a little different and weird, right? For one, the JSX stuff like this, that's all the same, right? But a lot of these other things are, can feel weird. Let's start with the first part. So how do we define a component in Reason? Well, let component equal ReasonReact.stateless component. You must use double quotes. There are no single quotes, sorry. And you must use semicolons. No opinions, right? Like, no opinions. Like, that conversation does not happen in Reason. Semis and double quotes. And there's two types of components that Reason offers. Stateless components, right, which is like your traditional like functional component, right? You don't have to write out the whole like React class thing. And then there's stateful components, which were actually renamed to reducer components because everybody was trying to figure out how to use Redux with Reason. But the best part was Redux was already built in, right? So they renamed it to reducer component if you want state. Anyway, let's look at the second half of that, right? So you'll see these squigglies. This is just a variable. This variable here is required. You'll also notice the underscore under children, right? And you'll also notice that we're not using children anywhere. Any variable that you don't use needs to be underscored. right? Just the same way, just the way you see it. And same with self. Self is sort of like your this in Reason, right? It needs to be underscored because we're not using it anywhere. Now, this sort of works the same way, right? The dot 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 component, the spread, you may have used that before. One thing that you don't want to do is this, right? We explicitly defined ReasonReact, that's this component, up here, and it needs to stay that way. Don't ever do this because it's a de-optimization, right? It'll make your code much slower. Anyway, now for the render method, right? The weird part that we're going to talk about here is just this, right? I think we understand how JSX button works, right? The weird part is this, right? ReasonReact.string. We have to go back to, like joining strings together using pluses, right? In this case, there's 2 of them. But what ReasonReact.string does is it doesn't turn this into a string. It actually turns this string into a JSX element, right? Because things need to be a certain type, and in this case, they must be the JSX type, right? You have to turn it into an element, right? Which is not something that we're used to in the JavaScript implementation. So, if you wanted to start using Reason today, and you just wanted to kind of mess around with it with something at work, right? It's really easy to add to an existing project, right? You don't have to just start a whole new project and go with Reason. You can bolt Reason onto your current project, right? You can open up a PR at work and, like, nobody would know, right? Maybe they would. But if you got enough flack for it, you just didn't have to merge it in and it wouldn't take you much time. So anyway, all you do is just install BS Platform. BS Platform is all the OCaml stuff wrapped up, right? Facebook knew that it had to make this approachable and as easy as possible to get people to use it, right? So instead of dealing with OPAM and Merlin and all that stuff that OCaml, has and is great, but is really hard to use, they just said, let's just use NPM. Let's use the current infrastructure that we have to introduce folks to this. So similar to your package.json, you had a bsconfig.json file. And that basically does the same idea, right? This is the name of my app. These are some of the dependencies. These are the sort of instructions that I want you to focus on, right? And then you just run this, equivalent to yarn build or React scripts build, right? BSB make world clean world. You can just put that in a watch function inside your scripts. And that's all you have to do to get started. Starting from scratch, or this is what the bsconfig file looks like. So I know it's a lot to kind of consume from where you're at, but basically the suffix, all of our files are going to have a .bf.js extension. These are the dependencies that we're using. So in this case, BS React Native and ReasonReact. We're using refmt. This is prettier, but for Reason, and so that's the version number. And then these are some compiler flags that we're using. So in this case, I get really nice error messages versus just nice something messages. Creating a new project is really simple too. Once again, you install the BS platform globally, and Create React App actually supports this out of the box. You just pass in scripts version Reason scripts, and it sets everything up for you the same way that Create React App works. Cool, demo time. I have to go walk over there now. All right. So, since I use React Native on a normal basis, I'm going to show you a React Native demo. So, let's try to get all this stuff on. Yeah. Okay, cool. So, what I did here is I just created a new, thing through Create React Native App, right? Create React Native App works the exact same way as Create React App, except as the name says, it makes you a React Native app. On the left-hand side, I've got my yarn start running for JavaScript, right? All the different errors that you see, all the stuff that you're used to. On the left-hand side, this bottom right corner, I'll make this bigger for a second. This is my Reason compiler, right? This is all the stuff that Reason outputs for me. And then up here, this is my just terminal. Anyway, so let's see. So we don't have Reason installed in this app yet, as you can see, right? In this case, this is just one file, app.js, and all the stuff a part of it, right? So what would it take to do this? We could do this the fast way, or I could just switch branches. I'm just going to switch branches because you never know with npm and yarn. Okay, so in this case, what I've done is I've run this command. So I added BS platform to my project. I scoped it, right, just so I don't have any version issues. And then I run yarn again, except I install ReasonReact and BS React Native. ReasonReact are the official React bindings. BS React Native are the buckle script bindings to use React Native primitives in Reason. Okay, so now if I open up this file, you'll see something like this, right? So this import label. I've created a folder in my directory called RE, and that's where all my Reason components will live. This is my source right here, label.re, and this is the compiled output, right? Let's take a look at that. So the JSX stuff and the React Native stuff might seem a little weird, right? Because you'll see all of these comments here, like, what the hell is going on, right? You can thank JSX for that, right? But as you can see, all of this stuff is pretty much fair game, right? You know, you may have a questionable developer that adds $signs in the middle of things, but once you start reading it, you know, like once you open up these files enough, it just seems like second nature, and it will, right? These comments, what they're doing is they are adding hints for you, right? So it seems like kind of crap that I want to stare at right now, but what it really is doing is offering the type hints from Reason, right? So in this case, I'm going to open up the source of this implementation so you can see what I mean. So up here, you see BS React Native, right? This is my global open. I define my component in line 3, right? ReasonReact.stateless component, got my double quotes, got my semis, right? Down here, I define a style sheet, right? So here's my local open, right? So I'm not writing BS React Native here anymore, right? Because I've got this one. But I also don't have to write style dot, border radius, style dot padding horizontal down nears, right? And that's what this local open does for us. Okay, so anyway, some weird things that you'll notice here, right? This whole string thing right here, right? This whole point thing right here, right? And some of these things have a dot with nothing after it, right? Well, that's because things are strict when it comes to typing, right? You must make sure that you pass in a certain type or things will break, right? So let's try that, right? What happens if I get rid of string here and just pass this in? Finish compiling. Bsconfig, bsconfig, no such directory. Okay, so this, I'm one step too far. Hold on a second, please. Bsconfig is here. Maybe I have to restart this. Yeah. Okay, cool. I think I screwed something up by switching branches, but anyway. Oh. This is why you don't do demos and meetups and conferences, because things break. Okay, anyway, we're just going to start this up again. Anyway, going back to the code, that's all we need to really look at. Label. Okay. So we're going to add that back while that simulator boots up. Anyway, so because things are strongly typed, you must annotate things correctly, right? You must make sure that you use a float for a font size, right? Or you use a string for a color, right? And you need to let them know that this is what's happening. And a lot of the times you may be wondering, like, how would I ever figure that out? Well, what's made my life a lot easier in all of this is looking at BS React Native source code, right? And this stuff is really hard to figure out, but bear with me, and maybe I'll make your life a little easier, right? So in this case, we want to figure out where the hell this padding horizontal point stuff is coming in, because I can't get this to compile, and I thought I could use a normal, right, like number or whatever, like I did for border radius, right? But padding horizontal is different. Why is padding horizontal different? The best way to do that is literally to type in padding horizontal here, and then look. Okay, so here, padding horizontal, the type that we see here consumes a value, right? We know that it's padding horizontal on the left-hand side, that's what it's called. And then we see this encode PT PCT value, right? So that's like weird. So what do we do about that? We go up here, right? And we notice that encode PT PCT value is a pattern matching thing. It can either be a point, or it can either be a percentage, right? And this is how you're able to figure out a lot of these weird types, right? It's not something that you're used to, right? Especially coming from JavaScript. But once you get this stuff down, you become much more productive. React was
fun. Is it function?
Yeah.
Okay, that's very fun.
Yeah.
So it's a matching function. Slightly different.
Oh yeah, sorry.
It's like it just omits the match, where you don't have to type match. It's a function that only matches.
I'll make this a little bigger. Okay, so React wasn't easy to learn by any means, right? And now you may have it down, but still find yourself in the same boat of like, how the heck am I going to do this? I've got 4 different ways of getting it done, right? With Reason, the learning curve is about the same, except that once you figure it out, you'll know the right way to do it, right? And all this stuff will just feel much more natural than where you may be with React today. Let's see if I get this. Oh, I messed something up. Anyway, we can just go back to the presentation here. So, to wrap things up, here are the resources: ReasonML, BuckleScript, right, and ReasonReact. ReasonML.github, BuckleScript.github, all these sites look exactly the same because they all use another Facebook product called Doxosaurus and does a really nice job of generating documentation. Otherwise, check out the Chicago ReasonML meetup. We do something about every month, and it's just a couple of us that want to learn and hang out. It's nothing official like this yet. It's just 3 or 4 people that get together, and we just like mess around. And as we mentioned at the beginning, chicagojs.org. Please check out JS Camp. Please put in a proposal. If you need help like coming up with ideas or just want somebody to review it, you can email either of us, Peter or Mike at chicagojs.org. Thanks, everybody.